Okay, and let me start by telling you what is networking. Of course, you have come for the CCNA course, and yesterday I told you Cisco Certified Networking Associate or Network Associate, right? So of course, you need to know what is network, or you have come for the networking course. So first, let me tell you what is networking. And let me ask you a simple question. What is a network, guys? Any idea what is a network? Even if it's wrong or right, it doesn't matter. Can anyone let me know what is a network?
The connection between different kinds of places.
Different kinds of places. Okay, no problem. Any other answers?
Networking, it's a group of computers that are connected to each other.
You can say like that also. So actually a network, so when I say I got some friends network, right, what I mean is that I have some friends. You can make that silent. Okay, so you'll have some friends, and these friends will be interacting with each other in the friends network. Am I right? Okay, similarly, now that you're gonna study the technical things, say we have got many devices. So say the answer that you are told, let me just say update the answer, or let me just edit the answer. Say you got a group of not places, or say a group of people, or a group of computers, you can say. Okay, so we'll have a group of computers, and these computers will be interconnected and they will be communicating with each other. So this process of interconnecting these machines, say that process called networking, and this environment is called a network. Clear? Okay, now again, what are the advantages of network, guys? If at all I have some computers, and if at all I connect these computers together, maybe like this, I've connected in some manner, I've just connected it. Okay, and what are the advantages, guys?
By networking, the communication.
Of course, the communication.
With the different computers.
Yes, that means this computer, the first computer, can communicate with the second computer, or the third, or the fourth. So these computers can communicate with each other, or can share the resources, right? It can be the hardware resources or the software resources, right? Okay, now I can implement security as well. I can tell this machine, the first machine, should communicate to the second machine, but should not communicate to the third machine. So security can also be implemented. Clear, guys? Okay, now so here, now let me show it to you here. Network and its components. You can read this: group of computers or devices interconnected to each other is called a network. The process of creating a network is called networking. And the advantages of network: share the software resource, hardware resource, and also implement security. Okay, now the basic components of a network is what we are going to discuss. Of course, you need devices or computers. When we are talking about the devices, say mainly we'll be talking about computers. So users will be sitting in these computers, and they will be sending a message, or they will be sending something to the other computer, right? So computer is it's a must for a network, or you can say computer is one of the main things for networking. Clear? Now the second thing is called NIC. Any idea what is NIC is, guys? Network interface card. Let me tell you. So even if you are not aware of this, don't worry. Okay, this is the first class and we are just discussing it. Okay, so now again, let me now tell you what is NIC. NIC means network interface card. Network interface card. So let me tell you, if you got a computer and the computer has got a CPU cabin, and in the CPU cabin you might have seen different slots. Example, USB slot. You know it, right? You can connect the USB, or you can connect, say, this thing. What do you say? Your pen drive or your mouse or whatever it is, you can connect to it, right? Similarly, you might have seen something like this. Okay, and you can insert a, what do you say, a cable. Yes. So this is the network interface card, or NIC, which helps you to connect to a network. Getting it? So this is the NIC. So the computers may have a built-in NIC, or you can insert an additional NIC. If you don't have, you can insert the cards. Okay, so that's why it's called network interface cards. Getting it, guys? Okay, now so the next is called the media. It's called the media. Media, it can be, say, or the media is the medium through which the data is sent. Suppose you are connected from the computer 1 to computer 2. So you can connect it from, or you can connect it via a cable, or you can connect it wirelessly. Right? So through the wire or through the wireless medium, you are sending the data. That means it's the media through which, I mean, it's that part or the, say, area through which you will send the data. That's called media. Clear, guys? Now at last you got one more thing called connecting device. Let me tell you about it. Just give me a moment, guys. Just give me a moment. I'll be back in a minute. Okay. Yes. So guys, the fourth one, which is the connecting device. Okay, now, yes, okay, so now guys, now let me tell you. So here, if you got some computers, suppose these are the computers. This is the first one, and the second one, I mean, suppose this is the second one. Yes. So third one and the fourth one. If you got 4 computers, right? Now to interconnect these computers, or if you want to send something from computer 1 to 2. Now the computers will have what it is. See, they will have an NIC, network interface card. So they have an NIC which helps you to connect from computer 1 to computer 2. Okay, so let me draw the NICs also. Suppose these are the NICs. Okay, so now I can connect from this first computer to the second computer and send the data. Okay, now if you want to connect, or if you want to send the data from first to the third machine, again you have to insert one more NIC and you can connect it from 1 to 3. If you want to connect from 1 to 4, what you will do? Again you will insert one more NIC and you will connect from 1 to 4. Clear? Now what if you want to communicate from 2 to 1? You will send the data like this. What if you want to communicate from 2 to 4? Say you will, again additionally you need to add the NICs and then you will connect it. Right, again what if you want to communicate from 2 to 3? Again you need to add the NICs in both the computers and you need to connect it like this. Now what about 3 to 4? Again you need to add NICs and connect it. Isn't it getting complicated? Yes or no? Okay, so to avoid the complication, what I'm going to do is I'm going to place an in-between device. I'm going to place an in-between device which is called a connecting device. It's the connecting device. And let me tell you, so the connecting device has got multiple interfaces. The connecting device has got multiple interfaces. Now what we will do is that we will connect to this connecting device. From these computers, with a single NIC, you can connect it to the connecting device. Done. Now, if you want to send something from computer 1 to computer 2, you can send it via the connecting device. Okay. Now, if you want to send something from 1 to 3, you can send it via the connecting device. So the connection we have made the connection easier by introducing a device called connecting device. Clear? So the examples of the connecting device, you might have heard of it. If you have not heard, no worries, we'll study. Okay, so hub is a kind of connecting device, or switch is a kind of connecting device, etc. So these are the connecting devices. Any doubts? Okay, so these are the very basic things, right? I suppose that you already know these things. Yes or no?
Yes.
Okay. Now, again, give me a moment. Okay, now, the next thing. So these are the basic things. Now, we'll talk about each of the component. Okay, the first component was computer. Now, already you know this. These things you already know it, but still we'll discuss. Okay, now, Now the computer consists of an input device, a CPU, and an output device. And extra one more thing is that the memory unit is also there. Now, the input device, you will say through the input devices, say suppose mouse, keyboard, like that, right? So you will input certain things or input the data, and say CPU will process it and will give you the output through the output device, such like monitor or printer or scanner, something. Okay, not scanner, printer. Okay, now again, from the CPU there is a memory unit. If you want to store anything, you will store this to the memory. Clear? Store the values to the memory. Whatever values that is processed by the CPU, that can be stored or that will be sent to the memory for storage. Now, so the CPU here consists of two parts, ALU and CU. Say ALU responsible for arithmetical and logical calculations, CU responsible for controlling all the parts. Right? Yes or no?
Yes.
Okay, now the memory. The memory unit is divided into two, the primary memory and the secondary memory. So the primary memory itself is divided into two. What are the primary memory, guys? RAM and ROM. Right? Okay, you have already studied it. Right? So random access memory and read-only memory. So primary memory, say primarily is divided into two, RAM and ROM. So RAM is random access memory, so randomly they can access, say if at all you have something, they can randomly access from that memory. That's why it's called RAM. And let me tell you, it's a temporary storage area. It's a temporary storage area. If at all if the power is not there, then you will not have the values in the RAM. Only when the power is there, you will have the values in the RAM. Clear? Now let me again tell you about the RAM. Whatever you run will be there in the RAM. That's an important thing. Whatever you run in the computer. So whether I'm running Zoom, or whether I'm running NFS game, or whether I'm running, say, the PowerPoint, say it will be there in the RAM. It will be running in the RAM. Now, ROM, read-only memory. It's actually a chip. It's actually a chip. And say the ROM, they have burnt in some programs in the ROM. They have burnt in some programs in the ROM, and one such program which is burnt in the ROM is called POST, power on self-test. Right? So let me tell you what it is. If you are not aware of the POST, let me tell you. Say when you turn on the computer, you might have seen the computer display flashing once and the keyboard lights flashing once and all. So that process is called the POST. So whenever you turn on the computer will check for the presence of all the components and say whether these components are working or not. And that process is called that process of testing itself is called POST. Clear? Okay. Now again, next thing. Say the primary memory, and there is also one more memory called secondary memory. The secondary memory, hard disk, SSD are the examples of the secondary memory. Clear? Okay. So this is the computer. Nothing more we need to study. We already know more than sufficient. Okay, now the next thing, NIC, the network interface card. So you can see this is the NIC. So say when you take the motherboard, you can just insert this NIC into the motherboard or into the respective slot. Okay, now again let me tell you, so here this is the wired one and this is the wireless one. You can see the antenna, so this is the wireless one. Now NIC is used to connect to other devices, to another devices, or it can be used to connect to a network. Okay, so the computer can be connected to a network using this NIC, network interface card. Now this NIC also consists of a chip, and it consists of a value, a burnt in value called MAC address. It consists of a burnt in value called MAC address. Are you aware of the term MAC address? You might have heard, right? Almost everyone might have heard of this MAC address. So MAC address means media access control. Media access control. Okay, it has got different names, say MAC address or burnt in address. I suppose you can read at the back, right? These things. So burnt in address, MAC address, L2 address, hardware address, physical address. It has got a lot of names. So these are the names of MAC address. Okay, now am I going faster or slower? Fine. Okay, now let me tell you, MAC address is a 48-bit address. It's a 48-bit. So when I tell you it's a 48-bit address, it means it consists of 48 zeros and ones. It consists of 48 zeros and ones. Now let me tell you what is bit. Okay, again just give me a moment. Okay, so 48 zeros and ones. Okay, let me tell you, so the bit here represents the binary number system. Binary number system. Okay, we humans use the decimal number system while the computers use the binary number system. Okay, so you might be aware of zeros and ones, right? So now let me just tell you 48-bit, but we'll convert this 48-bit MAC address into hexadecimal value. Into hexadecimal value. Everyone are aware about the hexadecimal value, guys? Yes or no? Sure? Okay, anyway that I'll tell you. Just again, pardon me guys, my health is not so well, so that's why just again pardon me for a moment. Okay. Yes guys, shall we? Okay, now let me tell you. So here I told you that the MAC address is a 48-bit address, but it is represented in hexadecimal value. Okay, so again you got another number system which is called hexadecimal number system. Hexadecimal number system. So let me just tell you about the decimal number system. Okay, the binary number system, or suppose hexadecimal and binary. Shall we? Yes or no? Okay, now decimal, you know, decimal numbers, dec means say 10. You got 10 numbers or 10 digits. Which are those 10 digits, guys? 0 to 9. Yes, so the decimal digits are say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, and after this, say you will keep on writing say these values like this, say 10, then 11, 12, 13, 14, 15, 16, like that. It will keep on going. Right, so actually you only have 10 digits, 0 to 9, and afterwards what you will do is you will write the combination of these numbers, 1, 0, like that. You will write the combination of the numbers. Okay, so now you can write infinitely some like what do you say, infinite kind of numbers, right? So it will keep on going like that, you know it. Now about the hexadecimal number. Okay, hexadecimal here means hex means 6, hexa means 6, and dec means 10. So total you have 10 plus 6, 16 digits. Total you have 10 plus 6, 16 digits. Let me tell you. So 16 digits means 0 to 9. It is fine, 0 to 9. It will be like this: 0, 1, then 2, 3, 4, 5, 6, 7, 8, 9. Up to here it's okay. Now the next digit is from A to F. It's from A to F. So the next one, the next value, or the value corresponding to 10, this value is A, and this value is B, this value is C, and this is D, E, and F. Clear?
But in smaller case, no?
No, in uppercase as well as smaller case. It is case sensitive. Okay. Now here in binary, when you write the binary, right? So the binary of 0 will be 0 itself. Yes or no? Okay. Now the binary of 1 will be 1 itself. There's no doubt in it, right? So, but instead of writing 0, let me write 0, 0, 0, 0. Any issue? No. I've just, in front of this 0, I've just written 3 more zeros. No issues at all. Right. Now, let me write this value. So the 1, you can write it like this. 1 you can write, and in front of that 1 you can put 3 zeros. Right. Now, to write 2, I'll be writing 0, 0, 1, 0. Anyone who doesn't know how to write the binary of this one? Anyone, guys? Let go of your ego. Yes or no? Okay. So let me now tell you how you can find this one, this value. Okay, so in decimal, what we are doing is we are keep on adding 1 here. 0 plus 1 is 1, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, like that we are keep on adding it. Okay, here also we'll keep on adding. We'll keep on add. So let me tell you, before going or before writing this one, okay, let me just tell you one thing. So in binary, 0 plus 0 is equal to 0 plus 0 is equal to 0. So guys, I need answers. Okay, and 0 plus 1, so I'm not talking about binary, so let it be decimal. 0 plus 1 is equal to, again I need more response. Again, 1 plus 0 is equal to 1. Yes, and 1 plus 1, what is 1 plus 1, guys? 2. Very good. So decimal, it is 1 plus 1 is equal to 2. Now let me just discuss about this one, I mean the binary value. So yes, 0 plus 0 is equal to 0, that is fine. 0 plus 1 is equal to 1. 0 plus 1 is equal to 1. Okay, now 1 plus 0 is equal to 1. Now the change happens here. 1 plus 1 you cannot write 2 because there is no such value called 2 in the binary. So 1 plus 1 is equal to 0 with a carry 1. This is how you will tell. 0 with a carry 1. It is as if you are adding 9 plus 1 in the decimal format. It will be 10. 0 with a carry 1, or you will call it as 10. Clear? So the same thing here. 1 plus 1 is 0 with a carry 1. Okay, so now what I'm gonna do is, sorry, so here you have the value 0 0 0 0. Everything is 0 here. Now I told you we are keep on adding 1 here. So again here also we'll keep on adding 1. Shall we? So when you add 1, 0 0 0 0 plus 1, what is the value here? 0 plus 1 is 1. And this 0 will be here itself. This 0 will be here itself. This 0 will be here itself. Clear? So you got the value 0 0 0 1 here. 0 0 0 1. Okay. Now to get this value, the value of 2, what you're going to do is, again you're going to add the value 1. So again, along with 1, so here this is the binary value of 1, and with 1 you will add another 1. So 1 plus 1, what is 1 plus 1, guys? 0 with a carry 1. Okay, so you're gonna add it. So 1 plus 1 is 0 with a carry 1. Okay, now that you have 1 and you already have a 0 here, so 1 plus 0 is 1. And this 0 will be written here, and this 0 will be written here. So what is the value of 2? 0 0 1 0. So that's why I've written 0 0 1 0. Now to write the next value, so 0 0 1 0 plus 1. So 0 plus 1 is 1. Now this value will be written like that, and this value will also be written like that. This 0 will be also be written like that. So this value will be 0 0 1 1. Clear? Now again I want to find out the next value. So again I'll add 1. So now what is 1 plus 1?
0 with carry 1.
0 with carry 1. And again 1 plus 1. Yes?
0 with carry 1.
0 with carry 1. And 1 plus 0? 1. And yes? Okay. This 0 will be written here. So the value here is, say, 0 1 0 0. Clear? So everyone okay with this? So guys, can you try to find out the binary of these values then? Now, by adding it. 0 1, yeah, you can write it in your notebook. Okay. Just write it in your notebook. Okay, take your time and write. Everyone done? Okay, so guys, then we'll discuss. So what is the value for 5? 0 1 0 1 0 1. Okay, want me to discuss here? Sure. Okay, so now what is the value of the next one? 0 1 1 0. Okay, now what is the value of the next one? 0 1 1. And the next 1 0 0. Very good. And the next 1 0 0 1. Again, anyone having doubts? Yes or no? No issues, we'll discuss. Okay, so now let me tell you. So if you have a doubt, which one you went wrong? Sixth one. 6. Okay, so now let me tell you 5. I suppose you have written a 5, right? 0 1 0 1, you have written it, right? So 0 1 0 1 plus 1. So 1 plus 1 is 0 with the carry 1. Now 1 plus 0 is 1, and 1 will be written here, will be written down, and 0 is written here, will be written down. So it is 0 1 1 0. Clear? Okay, so again, so this value, so maybe if at all you have made the mistake, no issues. Okay, so when you come tomorrow again, do it one more time and make it correct. Okay, now again, this value will be 1 0 1 0. Yes, now it will be, this value will be 1 0 1 1. This is 1 1 0 0, and this is 1 1 0 1, and this is 1 1 1 0, and this is 1 1 1 1. And now let me tell you an easy method to write it down. Okay, now so here let me just tell you. So if I write down a number like this, 32,768, which is a decimal number, it's a decimal number. Now I'll be telling this, the 8, this value as ones place, right? We have studied that in the lower classes. This is the tens place, this is the hundreds place, this is the thousands place, this is the 10,000s place. Okay, similarly, when you take a binary value, suppose 1101, I'll tell that this is ones place, this is not tens place, but this is twos place, this is fours place, this is eights place, 16, 32, 64, 120, like that it goes, right? So any idea why that we are writing it like this, 1 2 4 8, or why I have written 1 space, 10 space, 100 space, 1000 space, 10,000 space, etc. 2 raised to, yes, exactly. Let me tell you here. So what happens is that, say here in decimal number system, we got the base or the total values or the total digits is 10. So you will be writing the value will be 10 raised to 0 here, and this value is 10 raised to 1, and this value is 10 raised to 2, this is 10 raised to 3, and this is 10 raised to 4. So 10 raised to 4 is 10,000. That's how it got the value. Okay, now considering a binary value, let me tell you. So the binary value here, it consists of, say, only 2 digits. So the base is 2. So you will be writing 2 raised to 0. So 10 raised to 0 was that for decimal. Now for binary you will write 2 raised to 0th value, 2 raised to first value, 2 raised to second, 2 raised to 3, 2 raised to 4, 2 raised to 5, etc. So any number raised to 0, it is 1. Then this, say 2 raised to 1 is 2, 2 square is 4, 2 cube is 8, 2 raised to 4 is 16, like that the value keeps on going. Okay, now let me tell you an easy method to write it down, the combination. So here the value is 1 2 4 8, and it keeps on going, right? Now that 4 bits are necessary, so here what I'll do is that, so I'll keep on writing like this, 0 1 0 1 0 1 0 1, like that, because 1 says, say every value, for each one value it keeps on changing. Okay, now 2 here, it means 0 0 1 1 0 0 1 1, like that we keep on writing. Okay, so that means every 2 values will be repeated, 2 2 2, it will be repeated. Okay, now the next one, 4. So if you want to write, it will be 0 0 0 0. This number will be written 4 times. Okay, now 1 1 1 1. Again 0 0 0 0 1 1 1 1. Like that, it keeps on going like in a 4. Okay, now this one. So of course you can guess 8 zeros will be there and 8 ones will be there. So 1 2 3 4 5 6 7 8. Then the next 1 2 3 4 5 6 7. So 8 ones will be there in the next one. So this is also, this method also you can write. Clear, guys? Yes or no? Okay. So this is how you write the combination. Now let me tell you. So here, sorry, just give me a moment again. So let me tell you here. Yes guys. Okay, now let me tell you. So here what happens is that, say when I write the value, hexadecimal value of f, what is the hexadecimal? Say here, this is the value f. So the value corresponds to, say, 1 1 1 1, or you can say each hexadecimal value corresponds to 4 bits. Each hexadecimal value corresponds to 4 bits. So that means this is the first one, this is the second, third, and the fourth. Now MAC address, I told you, say it's a 48-bit MAC. If it's a 48-bit MAC, it consists of 12 hexadecimal value. It consists of how many values? 12 hexadecimal values. So the example of a MAC address, let me write it down. I'll write 12 hexadecimal values. Suppose 0001 A2B3 C4D5. So 1 2 3 4 5 6 7 8 9 10 11 12. 12 hexadecimal values I have written it. Okay, now I'll be grouping into 4. Means after 4 hexa I'll be writing a dot, after 4 hexa I'll be writing a dot. So this is how you will write a MAC address. Clear? Or you may write it like this also: 0001 A2 B3. In some places you can see written like this also, grouped in twos: 0001 A2 B3 C4 D5. So this is how you will write this MAC address. Clear? Okay, please write it down, the MAC address. Sorry? Okay, just nothing. Say in the second one we are just grouped in twos, that's it. Okay, grouped in twos means here we are grouped in fours: 1 2 3 4 5 6 7 8, like that. But here we have grouped in 2 only. 2 2 2 2, nothing else. Clear? And instead of the dot I have put a colon. That's it. Okay, now
Hello.
yes.
Yeah, this last one, this for the MAC address 12H, how we came to this number A2B3C45?
Yeah, just written an example of MAC address.
Okay, it's an example. Okay, fine. Yeah, thank you.
Now let me tell you, so this is how you will write the MAC address. Now, so here, just taken the example here, just written a value, a random value. Okay. So now, okay. So this MAC address, it is divided into two parts, or it consists of two parts. The first 6 hexadecimal, this part is called OUI. It is called OUI, or organizationally unique identifier. It is called organizationally unique identifier. Okay, now this is given by IEEE. It's given by an organization called IEEE, which is used to identify the organization. Clear? And the next part is called vendor assigned part. Vendor assigned part. This also you can write down. Organization unique identifier and vendor assigned part, and this second part is assigned by the vendor or the organization itself. Okay. Now guys, again let me tell you, so this is the NIC card. So I told you about the NIC, and then I told you about, say, the address which is present or which is burnt in the NIC, which is called the MAC address. Clear? Okay. Now we'll go on with the third one, the third requirement, which is called media. Okay, so media here, say, let me take it, or yeah, we'll discuss that also. Okay, so media, it's of two types, the bounded media and the unbounded media. Okay, bounded media means it is wired media, and unbounded media means wireless media. Okay, so the wired media here, the bounded media, you got a lot of cables, or you got a lot of wires, or it's called cables. So you got coaxial cable. Have you heard of coaxial cable? Yes, right. So of course you have seen it as well. So here, let me show it to you. This is the coaxial cable. So the cable TV connection and everything is coming via the coaxial cable, and previously it was used for the network connections as well. Okay, so now again let me tell you, so here they have an outer insulated jacket, a shielding wire mesh, a dielectric, and inside you will have a copper wire. So this is the structure of the coaxial cable. Now say this is the coaxial cable. Now the second is the twisted pair cable. Twisted pair cable also you might have seen it. Okay, let me show it to you. So this is the twisted pair cable. You can see this is the twisted pair cable, this one and this one. Even the twisted pair cable is of two types, shielded and unshielded twisted pair cable. Okay, shielded and unshielded. Now again, one more you might have heard of it, say optical fiber cable. Okay, the optical fiber cable. This is the optical fiber cable. Okay, so now before going more into this cabling, let me tell you some terms here. So these are the terms. Transmission type. Okay, you got two transmission types. See, the first is called broadband, and there is called baseband. So the broadband here means you are sending it as analog signal, and the baseband here means you are sending it as a digital signal. So that is the broadband and baseband transmission. Okay, so that is transmission type. Now the next term is called transmission mode. Transmission mode. You might have heard of it: simplex, half duplex, and full duplex. Yes or no? Okay. So simplex here, it means one-way direction. It means you are communicating from one way. Say, so you are sending something from A to B, and B cannot send anything back. Say only A is allowed to send back. So that is a one-way communication. Example, radio. Okay. Now, the second is called half duplex. Second is called half duplex. So that means, say A and B both can communicate, but not at the same time. When A is communicating, B will have to receive, and when B is communicating, A will have to receive. So it's, yes, example as walkie-talkie. Very good. Now, full duplex. Full duplex means at the same time you can communicate. A as well as B can communicate at the same time. Clear? So this is the transmission modes. Okay. Now, at last you got transmission methods also. Transmission method, the first method is the unicast, and the second is multicast, and the next is the broadcast. So unicast means one-to-one communication, one-to-one. Multicast means one-to-many, and broadcast means one-to-everyone in that network. Clear? And you got one more which is called anycast, one-to-nearest, one-to-nearest communication. So this is the transmission methods. Clear? Okay. So these are the terms that we need to discuss. Now the next thing, coming back, so coaxial cable is of two types, broadband coaxial and the baseband coaxial. And again guys, these are just for your information. So the CCNA doesn't cover these things at all. Okay, this is just for the information and the basic things that we'll be studying these things. Clear? Okay, so now again guys, just go through this table. Okay, just give me a minute and I'll be back again. By that time just go through that table. Okay. So guys, just let me pause recording. Let me start recording. Okay, so guys, now coaxial cables. I told you coaxial cable is of two types. The first is called, say, baseband coaxial cable, and the second is called broadband coaxial cable. Baseband coaxial cable and broadband coaxial cable. So now coaxial cable, baseband means you will be transmitting the baseband signals, and the broadband means you will be transmitting the broadband signals. Now the baseband coaxial cable is divided into two, thick net and thin net. So thick net here, it means, so thick shielding. Here it means you got thick shielding here. Now thin net means you got a very thin shielding only. Okay, now thick shielding here, and the transmission type is baseband, and the maximum bandwidth is 10 Mbps. So the bandwidth is 10 Mbps means 10 megabits per second. It's not 10 megabytes, it's 10 megabits per second. Okay, now here also you can see they got, the thin net has got thin shielding and the baseband transmission and 10 Mbps. Okay, 10 megabits per second is the bandwidth here also. Now the maximum length of the thick net is 500 meters and the thin net is 185 meters. Now the connector here is called vampire type connector, and here the connector is called BNC connector. Okay, so you don't have to go into these things and all. So this is just for say the sake of teaching you the cables that I'm telling. Okay, so now, so here and the application, say thicknet is used in cable networks LAN connection, while thinnet, say you got thinnet based LAN. So previously it was used. Now that we are going with some other technology. Okay, now, so this is the coaxial cable. Now let me just tell you about the next one. Say here twisted pair cable. The next one is called twisted pair cable. So of course you can see, say let me just zoom in, say, okay, so I hope you can see it clearly. So twisted pair cable is divided into two, unshielded twisted pair and shielded twisted pair. As the name suggests, shielded will have heavy shieldings. Okay, so here you can see, plastic coating is there. Again you got say some aluminum foil, and inside you got some mesh, and inside only you got some wires. Okay, here you simply got a plastic strip, and inside you got the wires here. You do not have the shieldings. So now you can see twisted pair. You got 4 twisted pair, or 4 pairs of wire which are twisted, right? So this is the green pair, this is the brown pair, the orange pair, and the blue pair. Okay, so now, okay, now you can see the green pair, it consists of 2 wires. The first is the green wire, and the second you can see a white wire, you can see, which is twisted along with the green one. Okay, now say this is the orange, the brown wire. Along with the brown you can see a white which is twisted. Now this is orange, and along with orange you can see a white wire which is twisted, and along with the blue you can see a white twisted. So here each wire has got, yes, so each wire has got its own name. Let me tell you the names also. Okay, so this wire, the solid green wire, is called green. Okay, just give me a moment. Yes, the solid green wire is called green itself. This is the solid green wire. Okay, now the white which is coming along with the green, it is called white green. White green. Now the solid brown wire, it is called brown, and the white which is coming along with that is called white brown. Now the solid orange wire, it is called orange, and the white which is coming along with that is called white orange. Now you got blue and white blue as well. White blue. Clear? So this is how you will name these wires. Okay, so white green, green, white brown, brown, white orange, orange, blue, and white blue. Okay, now again this unshielded twisted pair, okay, this unshielded twisted pair has got many categories, or UTP categories. So category 1, category 2, cat 3, cat 4, 5, 5e, 6, 7, etc. Okay, so now here you can see category 1 is the broadband, whereas others are baseband transmission. Okay, so now category 1 was used in the telephone lines, whereas cat 2 and all, you got different say uses for those. Okay, now so cat 2, here you can see the difference is that cat 1 has lesser than, the bandwidth was lesser than 1 Mbps, and cat 2 4 Mbps, 10 Mbps, 1600, 1000, 10 Gbps. So the bandwidth is what it differs. Clear? Okay, so this is the UTP categories, or unshielded twisted pair categories. Now I hope cat 7 is being used. Okay, they might have started using cat 7. So far they have been using cat 6 and cat 5e. Now that you can see cat 7 is also being used. Clear? Okay, now the next thing, say we'll come to this a little bit later. Okay, now optical fiber. So optical fiber, let me tell you, so you might have know about, or you might have heard of the optical fiber, right? So you will have an inner one, or this optical fiber has got 2 parts. The outer part is called cladding, and the inner part is called the core. So now you will pass the light rays through this optical fiber cable, which will get reflected, and that property is called total internal reflection. You might have studied it in the lower classes in 9th or 10th or something, Okay, so it's the total internal reflection. That property is being, say, utilized here in the twisted pair, this optical fiber cable. Okay, now this optical fiber cable, you got two types, multi-mode and single mode. Okay, so multi-mode here, it means you can pass multiple light rays. You can pass multiple light rays. So the light rays will be going like this. Okay, now in single mode, you will be passing only a single light ray here. It will be passing like this. Okay, now single mode is preferred for long distance communication over multi-mode. Okay, and you might be wondering, or have you ever thought of how the continents are connected, guys? How the continents are connected? Of course, you got underwater sea cables. Underwater cables. Okay, so the underwater cables, to connect the continents or to connect the countries, you will be using the optical fiber cables. Clear? Okay, so this is how the connection is going. So this is the optical fiber cable. Now the optical fiber cable has got different bandwidth, because they have got different grades of optical fibers. Okay, don't want to go into those grades. Okay, now so this is the optical fiber cable. Now coming back to the twisted pair cable. Coming back to a twisted pair, I told you got 8 wires. You got 8 wires, and the 8 wires can be arranged in certain manner. The 8 wires can be arranged in certain manner. So you can arrange it using two methods. The first method is called, say, 568A, or it is called 568A standard, and the second arrangement is called 568B standard. Okay, so 568A standard or 568B standard. Now the arrangement is called crimping. The arrangement is called crimping. So when you hear the term crimping, you need to know what is it. Say you will arrange it in a specific order. You will connect the connector. So this is the connector. This is the connector. Yes, and this connector is called RJ45 connector. RJ45 connector. Now you will connect the cable like this. You will arrange it and you will connect the cable, and after connecting you will crimp it, or you will, say, punch it using a crimping tool. Clear? So that process is called crimping. And arrangements are of two standards, 568A standard and 568B standard. So the 568A standard here, say, you can see here. So here you can see this is the 568A standard. First is white green. So you can see this is white green. So here white, if you have noticed it here, again just give me a minute. So if you have noticed it, you can see some stripes over here. So the white, this is the white wire only. Okay, but along with the white you can see some blue stripes. Can you see it? Okay, so now here also you have seen, right? Okay, so here also you can see along with the green you can see a small green stripe. I mean, along with the white wire you can see a small green stripes. Now along with the, say, the white brown, you can see small brown stripes, and along with this white, say white blue, you can see small blue stripes, so that you know which wire it is. So if at all you have the plain white wires, you do not really know which wire it is, right? Whether it has come along with the blue, whether it has come along with the orange or green or brown. So to differentiate that, to differentiate the white wires, you will have a small, what do you say, strip or stripe along with that wire. Okay, now yes, so here this is the arrangement. So now this crimping, so the first one you can see this is white green. It's the white wire with the green stripes. So this is the white green, and the second is the green wire. This is the solid green wire. Now the third is the white orange. You can see, say, white, yes, just
2 minutes.
Yeah.
Or I'll go and collect the feedback from Sharat Plus and come back.
okay. So now, so the third one is the white orange. Okay, white orange means is the white wire only with orange stripes. Now this is the fourth one is blue, and fifth one is white blue, then the sixth is orange, then the seventh is white brown, and the eighth is brown. So if at all you go, so previously they were asking the interview level questions like this. Okay, now I really don't think that they'll be asking, because say nowadays this is not so much significant. Previously it was significant. So when say just some years back, when I went to say maybe like 3 years back, I suppose, when I went for an interview, they asked me about this crimping standard or not. Okay, so they asked me what is the crimping or the color coding of 568A standard and what is the color coding of 568B standard. Okay, so 568B you can see here, if you can notice, say 1, 2, 3 and 6th wire are different. 1, 2, 3 and 6 are different. So now let me write it down. So here, so in 568A, the first is white green, then it's green, then white orange, blue, white blue, yes, it's orange, white brown and brown. This is the color coding. Okay, now 568B here, see this color coding is different. So the first, it will be white orange. Instead of the green, you have orange here. Wherever there is green, it is replaced with a orange. Okay, so this is, the first one is white orange. Then the second one is orange. And wherever there is orange in 568A, it has been replaced with green. Yes, so this will become white, green. Now the fourth one remains the same, blue, and the fifth one remains the same, white, blue, and the sixth one here, it is green. And this is white, brown, and this is brown. Clear? So this is the color coding. So I told you 1, 2, 3 and 6 is where the change comes. Here the white green has become white orange, and here the green has become orange, here the white orange has become white green, and here the orange has become green. Clear? The rest are the same. You can see blue and blue, white, blue, brown. You can see it. Right guys, got it? Okay, now so this is the color coding. Okay, now so I suppose everyone has an internet connection in your home, right? So today go and check your internet connection. Say you might have, say, if at all you have a desktop PC. Okay, then if at all you have connected it wired, say in a wired manner to the modem, you might have connected it using this twisted pair cable. Twisted pair cable. Okay, so you might have seen this connector also. You might have noticed this connector, right? Yes or no?
Yes.
Okay, so you can check, say you can check this. So this is how you need to check. Okay, the clip, you will have a clip and the clip should be coming in the back side, and the front side you can say check it from the left side. The first wire is this one and the second, third, fourth. So which standard it is, please check it. Both the end you can check. Clear? Okay, now so that is one task that I'll give you today. Now let me tell you, now a cable has got two parts. A cable has got two parts. So this is the cable. This part or the left side can be crimped using 568B standard, right? So it can be arranged like this: white orange, orange, white green, like that. It can be arranged, and suppose it is crimped with 568B, and this end also can be crimped with 568B. If both the ends are same, then that is called straight through cable. If both the ends are same, then that is called straight through cable. Now let me tell you, so here if both the ends are crimped using 568A and here also 568A, both the ends are same, so that's also straight through cable. So straight through cable means both sides use the same crimping standard. Clear? Okay, now the next one. Now so again let me tell you, so here, okay, so let me again make it bigger. You can see why it's called straight through. Let me tell you. So here 568B is crimped, right? Now the first wire, where is it? Just give me a moment. Yes, this is white orange, this is orange, white green, blue, white blue, green, white brown and brown. Okay, now the same is crimped over here: white orange, orange, white green, blue, white blue, green, white brown and brown. Okay, so you can see here, say white orange, is the first wire which is coming as the first wire here also. So the first cable will be coming 1 and the second cable will be coming here as the second. The third cable will be coming here as the third. The fourth will be coming here as the 4, 5 to 5, 6 to 6, 7 to 7 and 8 to 8. And that's why it's called straight through cable. It's called straight through cable. The same is applicable here also. 568A and A. So the first white green wire is coming as the first wire itself. So 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6, 7 to 7 and 8 to 8. The connection goes like this. And that's why it's called straight through cable. Now the next one. So now the crossover cable. Now let me tell you about the crossover cable here. So the crossover, of course, you can guess it. So here previously we have crimped the same standards on both ends. Now at both ends we are having different standards. You can see at first end you are having 568B and at the second end you can see 568A. Yes or no? Okay, so now let me tell you. So here 568, say the first is 568B, so it is white orange. White orange, now let me write it down here, say again. Okay, so this is white orange and this is orange, this is white green and this is green. And here the crimping is like this. 568A, it is white green, green, white orange and orange. So now let me show it to you here. The first wire, which is white orange, is coming and here it is going to the third wire. It's going to the third wire. You can see this white orange. Okay, now the second wire, which is orange, is coming and it is coming to the sixth wire. Now this is white green is coming to the say the third one is coming to the first one. So first is connected to third one, second is connected to a sixth one, and the third is connected to the first one, and sixth is connected to the second one. You can see the crisscross lines here, right? If both the ends are crimped using different standards, then that is called crossover cable. What is it called? Crossover cable. Clear? Okay, so this is the another thing. Okay, another cable. Now you got one more cable. Let me tell you about that also. Okay, it's called rollover cable. It's called rollover. Suppose you have crimped 568B here. Sorry, 568B. Now 568B, you can see the first one is white orange and the second is orange. So now let me tell you, you are reversing the order. You are just reversing it. So here the white orange will be coming as the last one, and the orange will be coming as the second last one, and the white green as the third last one. So here you can see that, right? So 1 2 3 4 5 6 7 8 is now being replaced like say 8 7 6 5 4 3 2 1. So it is the reverse. This is just the opposite of 568B here, and that's why it's called rollover. It's just one time, it's just rolled over. Got it? So this is the rollover cable. Clear? Any doubts in this one?
No.
Clear, guys? Everyone?
Clear.
Okay. Now, yes. Now we'll go to the connecting device. Okay. So the connecting device, the first one is called hub. The first one is called hub. So hub is a connecting device. So here I've drawn hub here, or I've drawn a connecting device here. Let me just take that. Yes. Now this is, suppose this is hub. This connecting device is hub. Now let me tell you more about hub now. Okay, hub has got certain properties. The first property is called signal regeneration. It's called signal regeneration. Okay, let me tell you what it is. Okay, so here, if at all, suppose you have connected the devices. Just a moment. Okay, suppose you have a computer here. In our classroom we got a computer. Now, so maybe some, say suppose 200 meter apart, or suppose 150 meter apart, we have another device connected. Okay, so we want to connect from this computer to this computer, which is 150 meter apart, suppose. Okay, so what happens is that whenever you send the data, suppose you are sending the data, whenever you are sending the data will be going, and when it reaches this computer, it will be very feeble. The energy will be lost, and they cannot say retrieve this message back. Clear? So this energy has gone, or this computer will not able to understand what is the message here. Clear? So if you have kept say a hub in between, so what hub will do is that hub will regenerate the signal. Hub will do what? He will regenerate the signal. So here what happens is that it is connected. If you want, you can close it. Okay, so now the hub will, so here if at all the energy has gone, say when it, say he will convert it, or he's not converting, he'll boost it. That's the exact term. He'll boost it to the predefined level. Okay, so if it is say like 10 volt or something, here also it will be 10 volt. He'll boost it to the predefined level, and this process called signal regeneration. Clear? Okay, now the next property, let me tell you. So this one you will talk about it later. Just understand that, say it's a physical layer device. Okay, it's a physical layer device in the sense, say it works in physical layer. The layer things and all you will study it later. Okay, just understand it's a physical layer device. Now the next one is called hub. Sorry, the next property of the hub is fewer number of ports. It has got fewer number of ports here. Again, let me tell you, the hub doesn't have that much port. The maximum port, it can be up to 16 ports maybe. After that you will not have, say you will not find any other ports in the hub. So the hub has got only a fewer number of ports. And you got some disadvantages of the hub also. Let me tell you what it is. Signal broadcasting and bandwidth sharing. Signal broadcasting means here, where is it? Say, suppose, so this is the computer. So if at all this computer, suppose this is the hub. If at all the computer is sending something, then say the hub will broadcast it to everyone. It will broadcast to everyone. Suppose the message is sent from the first computer and to the second computer. Then also the hub will always do the broadcast. It will always do the broadcast. Okay, it will broadcast to everywhere, to the second machine, third machine, fourth machine, to everywhere it will broadcast, including the source interface. That is another disadvantage. So the hub will always do the broadcast. Clear? Okay, so again, just give me a moment. So it will always do the broadcast. So the broadcast will be done to the source interface also. Got it, guys? Okay. The next disadvantage is that the bandwidth sharing. Bandwidth sharing means, suppose if you got a 100 Mbps connection here, then the bandwidth will be shared among these interfaces. All the interfaces will be, say here, they will share it like 25 Mbps, 25 Mbps, 25 Mbps, 25 Mbps, like that they will share it. If you have, say, 10 machines here, it will be, each interface will be having 10 Mbps connection. The bandwidth will get shared, or you do not have specific bandwidth here for each interface of a hub. Clear? That is another disadvantage. And one more disadvantage, let me tell you. Hub is considered as a non-intelligent device. It is considered as a non-intelligent device. So here, let me tell you what is or how I shall define this intelligent. Okay, so if I tell you that a machine is intelligent means, say the machine has, or the machine keeps track of the, say the computers here. Okay, suppose if it's a switch. If it's a switch, the switch knows to the upper left corner the first machine is sitting. To the upper right corner the second machine is sitting. To the lower left corner the third machine, and to the lower right corner the fourth machine is sitting. The switch keeps track of all these information. Right? So the hub doesn't keep track of all this information, and there is one reason, say this hub will always do the broadcast. He doesn't know where to send it, so he'll send it to everyone. Clear? Okay, so that is another disadvantage of hub. I hope you have understood. Okay, now guys, we got another device called, so these are the disadvantages of hub and switch also. The next device is called switch. So switch, understand, it operates at data link layer. The layer things we'll study later. Okay, so just understand it operates or it works at data link layer, or say it works in layer 2. It works in layer 2. Okay, so now switch has got multiple ports. So it depends upon the model of the switch, how many interface the switch has. It depends upon the model. Okay, some switches will have 96 ports, some switches will have more than 100 ports, like that. Okay, now switch performs signal regeneration. Okay, now say no unnecessary broadcast. So in hub, I told you the hub will always do the broadcast, but switch will not perform unnecessary broadcast. He will perform broadcast, but that is called flooding. And moreover, he doesn't perform unnecessary broadcast. Getting it? Okay, again, just give me a minute. Now, it performs signal flooding. Let me tell you what it is. Okay, so here, suppose this machine is sending a broadcast message. That machine is sending a broadcast. Okay, so if he is sending a broadcast, let me tell you, this broadcast will be sent to all the machines, will be sent to 2, 3 and 4. Okay, excluding the source interface. That means it will not be sent back to the first machine. Clear? So that process is called flooding. Okay, now sending or broadcasting to all the interfaces excluding the source interface, that is called flooding. Clear, guys? Okay, now it performs flooding when required. Now it is an intelligent device. I told you why it is called intelligent device. Now one more specialty of the switch, it consists of a specific or one dedicated hardware. It consists of a dedicated hardware which is called ASIC, application specific integrated circuit. Getting it? So this hardware makes the switch unique and it makes the switch special, because you got a dedicated hardware for switching purpose which is called ASIC. Clear? So this is the switch. Any doubt? Yes or no?
When there is a flooding, it will reduce the bandwidth. Right?
Yes, you can say. Okay, not really. It will not reduce the bandwidth. It will consume the bandwidth. Okay, that is the exact word.
I mean, the usage will be high.
Yeah, usage will definitely be high. Okay, but that's why I told, say it does the flooding only when it's required. When it's required, it will do the flooding, or else it will not do the flooding. Clear?
What's data link layer? What's the data link layer?
You will study. Now that if I tell you, you won't understand. Okay, you will study about the layers maybe in the upcoming, say maybe after 2 or 3 classes you will study. Okay, yes. Now guys, we got another device called a router. Okay, suppose that, let me tell you, say in our classroom, so suppose this is our CCNA classroom. In CCNA classroom, you got many computers here. So these computers can be interconnected, or these computers can be connected to a switch. Right? So here I've drawn it. Say here, suppose this is a switch. So these computers can be interconnected using a switch here. So now, suppose, let me draw it here itself. Or here. Yes. These computers can be interconnected to a switch, and suppose in the next classroom, which is CCNP classroom. Okay, so this CCNA classroom and this is CCNP classroom. You got multiple computers here, and these computers can be interconnected using another switch. Clear? Now, so this is one classroom or one network, and this is another classroom or another network. So to make these computers, I mean the computers in CCNA communicate with computers in CCNP, or to communicate from one network to another network, you will place another device called router. You will place a device called router. And from this switch, you will connect it to the router. Say the switch has got interfaces, and you will connect it to the router's interface. Okay, so the router is a device which helps you to connect different networks. Clear? Okay, so that is a router. Okay, I suppose you have called it that also, right? Okay, now, so it operates at network layer. Now this also we will study later. If I tell you, you won't understand now, you will study it later. Okay, now it is, say the router connects different network. It consists of minimum 2 interface. Only if it consists of minimum 2 interface, then only they'll be able to connect minimum 2 networks. Clear? There, getting it? Okay, so this is the router. Now you got some more devices. Say firewall is a device. Say IDS or intrusion detection system, that's also a device. Intrusion prevention system, that's also a device. Modem is also a device. You got lot of network devices. Okay, so firewall, what it does is, so these devices are security devices, not modem, the other one, the firewall, IDS, IPS and all. So these are, say, security devices. Okay, so the firewall, what it does is, say if at all you are receiving many messages, say it will filter the message and will send only the required ones, only the, say, the correct ones, or the, say, the genuine ones will be sent, where it will filter. So that's what is called firewall. So it will filter off or filter away all the unnecessary messages. Clear? Now the next one is called IDS, or intrusion detection system. Intrusion detection, so you need to detect the intrusion. So IDS will detect the intrusions. Okay, now you got intrusion prevention system, which detects and prevents the intrusion. And you got modem. Okay, modem, so modem performs modulation and demodulation. Okay, so this is the modem. Any doubts, guys, here also? These are the small things. Okay, so in CCNA you will be working with a routing and or router and switches. You will be working with routers and switches. Okay, you will be configuring Cisco routers and Cisco switches. Okay, now
What's modulation and demodulation?
modulation and demodulation means, suppose you are sending something, say you want to send a message, right? Say if you want to send a message, of course you might have heard of it, right? Say you need to have a carrier signal, right? This is the message signal and this is the carrier signal. So the carrier signal will be of higher frequency or will be having the higher, say, range. Okay, so of course to carry this message you need carrier signals. So to carry, so that is the process of modulation. Okay, you will carry that signal. Clear? So that is the process of modulation. Okay, and at the receiving end you will demodulate it so that you will get back this message. Clear? Okay. Now you got some more devices called the endpoint devices. So far we have been discussing the, say, connecting devices. Now you got some other device called endpoint device. Of course you can guess it. Endpoint means the end devices or the computers or the mobile phones. So the users might be using the computers or the mobile phones or something. So those are the endpoint devices. Machines acting as the end device like laptop, desktop and mobile devices. These are the endpoint devices. Now along with these laptop, desktop and mobile device, say you got another end device that is called the server. Server is a machine which provides a service. Server is a machine which provides a service. It can be many services. It can be DHCP service, DNS service, WDS, FTP, lot of services are there. Let me tell you each. DHCP means Dynamic Host Configuration Protocol. Means, I told you that, say, or let me just tell you, if you want to communicate, suppose, yes, what is your name? Srikanth. Okay, suppose we have Srikanth here. Okay, so if we have Srikanth, yes, and suppose this is my name, Bharat. So if at all I want to call him, I'll call him, hey Srikanth. Only if I know his name only I can call him, right? So, or say names are used to identify ourselves, right? So Bharat, so when you hear the name Bharat, you know that it is me. Now when I call Srikanth, or when you hear Srikanth, you can identify it is him. So the name is used to identify. Similarly, the computer doesn't have names but has some addresses. One such address is the MAC address that you have studied. Right? To identify the computer, you got something called MAC address. Clear, guys? Now, the MAC address is there, and also another thing is there which is called IP address. It's called IP address. Okay, so IP address is also there. So now, talking about the IP address. So IP address is also necessary for communication. That means the computer should have the IP address here, or the devices should have IP address. Okay, now let me tell you again. So the mobile phone that you're using, or the computer that you are using, so these devices has got an IP address. But have you ever checked the IP address, or have you ever noticed what is the IP address of the device?
Yes.
Yes, some of you might have noticed. Some of you might not have also noticed, right? Say you might have or might not have, or let me again tell you. So you can configure the IP address. You can configure the IP address. But as an end user, maybe you would have known it by referring to Google or something, right? Before that also you were Googling, right? Before that also you were using Facebook. Before that also you were using the Twitter. At that time also the computer was having an IP address. But you didn't set an IP address, right? Maybe you wouldn't have set an IP address so far. But the computer is getting an IP address from where? From a server called DHCP server. Getting it, guys? So the DHCP server provides a service. It provides what service? It provides the computer with an IP address. That's the service it provides. Clear? So DHCP server provides a computer with the IP address and the related parameters. Okay. Now DNS server, it also performs another function or another service. Let me tell you. So whenever you type www.google.com, the computer doesn't know the google.com and all. It works on IP address. It works on IP address. So when you type www.google.com, this google.com should be translated, or should be changed to its IP address. Clear? So this translation, this name is called domain name. Domain name. So this domain name to IP, or the domain to IP translation and back, is done by the DNS server. Clear? Then the next, WDS. Suppose if you want, or if you're working in a company with 100 computers or 1,000 computers, and suppose that they have purchased the computers recently, and they have not started using the computers. As a system admin, you are supposed to install the Windows operating system in all the 1,000 computers. In that case, let me tell you, so the WDS server will help you to deploy, or will help you to install the Windows operating system in all the 1,000 computers. Or else you will have to connect the computer to, the pen drive to the computer. You will have to install it manually, right? That is difficult for us. So to make our work easy, we have something called Windows Deployment Server, or WDS server, which will help you to install the operating system in all the 1,000 or in all the computers. Clear, guys? Feeling sleepy? Okay. Now the next server is called FTP server, File Transfer Protocol. So File Transfer Protocol server, or FTP server, is where you will store your files and folders. If at all you are working in a company, you might know about it. You are not supposed to download your files, your private files and all, right? You are only supposed to keep your company related, or the organization related details in the computers. You are not even supposed to take your mail, the personal mail also. But nowadays the company is not so strict and all. You can take. But they'll be monitoring these things. Now let me tell you, so the company related things, suppose the organization related things, they might be, when you go to the organization for working, they might give you some training, or they might give you some videos to refer, or they might give you some files to refer. Right, those files and everything can be accessed from a server called FTP server. Clear? Or you can copy the files to and from the FTP server. Clear, guys? File transfer protocol server. So this is the server. Understood? Okay. Now guys, now let me just, yes, almost time. Okay, so guys, we are not winding up. Say, let me just pause recording.